This is Lord Kelvin said. If you cannot measure it, you cannot improve it. All right, let's see. How do we measure the existing system? How to measure is the next step. What to measure is more important than how to measure. And then we should now come back to how to measure. Like for example, what are the metrics? Establish a valid and reliable metrics to help monitor progress towards the goals. In the case of pizza, what we are talking, if the critical to quality is temperature and we have established that the oven temperature should be between this degrees, say, let's say that it should be between 60 to 70 degrees or 70 to 80 degrees, you'll have to make sure that you start measuring those. Okay. So establish valid and reliable metrics to help monitor progress towards the goal. It's not only measurement of two things. One is the result, one is the cause. RC, result and cause. So the result is y/x. The result is a y and x is the cause. Y is a function of x. Y is equal to f of x. Y is the function of x. Now, x can be multiple x's. X is a cost, y is a result, and there can be multiple x's, multiple causes. For example, temperature might be one cause. Somebody said ingredient also is a cause. So temperature might be the cause, the ingredient. So the causes might be three things. Three primary things. Okay, first see these three primary things. 3M. The 3M is primarily look at these things: man-related causes, machine-related causes, and material-related causes. In case of pizza, let's see what can be the man-related causes. Maybe the man has not mixed it properly. Okay, and what is the machine-related causes? Maybe the oven temperature is not good. And material-related causes, maybe man, machine, material. 3M is man, machine, material. Okay, and material-related, maybe the ingredient what we have had, probably it is charring much more than the actual ingredient. Now we need to determine the current baseline. So we need to measure the results also. We need to measure the causes also. And we need to establish the relationship between the cause and the result. Another example I'll give you. Suppose if they say that the coffee taste is not good. If the coffee taste is not good, I'm talking about a milk coffee, okay? Now, if the coffee taste is not good, then the result is taste is bad. So every time you change something in the coffee ingredient, you need to taste it and see the result, whether it is tasting better or not. Now, the milk could be adjusted, the decoction could be adjusted, the water quantity could be adjusted. Okay, so the point that I'm trying to say here is you have to measure the ingredients, the excess. So the reason might be the milk, the reason might be the decoction, the reason might be the water. Okay, so these are all the causes, and the result is the taste of the coffee. You need to measure the results also, you need to measure the causes also. How many of you are clear what I said now? So which means when we are actually measuring, you will measure the results as well as the causes. You will start establishing the relationship between these causes and results. For example, if you start establishing the relationship, you might say one cause might have significant impact on the result than the other cause. One cause might have significant impact on the result by the other causes. Putting it the other way, some causes may not have any impact on the results. Cause may not have, and some causes might have little impact on the results. So which means there are a few causes which is having a significant impact, and there are a lot of causes which is not having a significant impact. Vital few, trivial many. I'll come back to this when we talk about the cause and effect diagram, fishbone diagram, Ishikawa diagram. Vital few and trivial many. And this is the foundation for hypothesis testing. I'm leaving you with a googly, okay? Hypothesis testing, which means you can do multivariate analysis. You can do design of experiments. You can do analysis of variation. But the fundamental is there is a relationship between the cause and effect, and some will have more relationship. If there is no relationship, there is no correlation. We'll talk about correlation regression in one of the tools. Okay. In some cases, there can be a strong correlation, some can be weak correlation, some can be no correlation. Okay. So this is on the measurement of the existing system. Okay. Let me finish one more slide on measure. So measure this process performance. We use what is called process map. We will also get into the details of process map. Okay, how to do a process map, how to record the steps in the process map, how to record activities in the process map, etc. Then we will measure the capability of the machines, the capability of the process. We'll call CP and CPK. Just, later on I'll explain you what it is, okay? Process capability index, whatever it is, capability analysis. We spoke about the Pareto charts also, vital few, trivial many, right? The Pareto charts. Like 20% of the causes contribute to the 80% of the solution, okay? If you attack 20% of the causes, you will get 80% of the solutions.